Hi, I'm Jake Burkett from Gralian Games, and I'm going to talk about the FMV code that I've written for Forbidden Solitaire. So Forbidden Solitaire, we've got a Steam page up for that now, and you can go and please click the old wishlist button. It's a horror solitaire game that we are making with our friends at Night Signal Entertainment, who made Home Safety Hotline. We obviously made Ancient Enemy, Regency Solitaire, and a bunch of other things. And this is a horror solitaire game, so it's quite a unique concept. And when we put the trailer out recently, it was really popular and got sort of 7,000 wishlists in 2 days, and then continued to do pretty well the following weeks. Got a bunch of press and stuff. So we were very surprised and pleased with how people responded to it. And one of the things about the game is it's basically based around you, the player, finding a 1995 CD in a thrift store, and you take that game home. You remember hearing about it at the time, and there was some controversy about the game, and the game never was released or something, but you find it in a thrift store, you take it home and you run it on your PC, and then discover what all the fuss is about. And basically, yeah, there's a problem with this game, which you will encounter as you play and uncover as the mystery as you go along. But I'm not going to go too much into all that. This is actually quite a technical video, and it's going to be me nerding out how I coded the FMV code to read in GIF files and how I optimized that to speed it up 3 times. So I'm just going to delve into that now. Don't worry if you get lost. Maybe some old school programmers will understand what I'm doing, but let's have a look. So that's the game page. If I open up Blitz Max, this is what I'm using to make Forbidden Solitaire. Now, I'll explain a bit about Blitz Max. It came out in 2004, so it's actually closer to 1995 than now, right? So I'm actually using quite an old tool. There's 2 versions of Blitz Max out there. There's the original vanilla version, which I'm using, 1.48, and there's the NG next generation version, which is 64-bit and is sort of supported by community. And actually I haven't upgraded to that, and I might do for my next game. But because I've built an engine for all of our games in Blitz Max, I'm using it for Forbidden Solitaire for speed, and it works very well for me. Now, there are a few issues with it, such as it being 32-bit, which we're going to get into later, why that was causing a problem with reading in and displaying movies. But basically, Blitz Max is, when people look at it, they say, is this a basic language? Because it's got like for and next and if and then and stuff like this. Where's an if and then? I can't really see one now. Oh, there. And it sort of looks like basic, but it's not really. It's kind of an advanced script which is compiled in and it sits on top of C++ libraries. So when you compile this, really each command is linked to a load of C++ code, and so you get an executable which runs as fast as if the whole thing was written in C++. So it's actually very fast. It's not like a interpreted basic on the fly. And I find it easier to use. It frees me up from thinking about pointers and everything else, because this is more like C#, and there's some sort of nice memory management and garbage collection going on for me, the programmer. So, you know, I've really enjoyed using Blitz Max. I normally use it with an IDE, this thing down here actually called Blide, but I'm running the basic IDE that comes with it to show you some test code, right? So I'm not showing the game code today, that's a different thing. This is some test code I wrote to test out the FMV GIF, reading and streaming, and how I optimized it, right? So this basic IDE is really basic. You kind of read the file in, you can have a couple of tabs open, you can compile it. There's not much you can do, whereas the other IDE I've got has got debugging and some, more features you'd expect from an IDE. It's still a pretty old IDE, but it's better than this sort of glorified text editor. Okay, so yeah, one of the issues with Blitz Max is there's no support for reading in movies of any kind, like MPEGs or whatever, which you might get with Unity or something else. Probably Unreal's probably got something like that, but there was nothing like that with Blitz Max, so I had to write some kind of movie player. And I was thinking, well, I could do this by having a sprite sheet perhaps that is read in and then showing each frame of the sprite sheet. But of course, I'd need to either write a tool or find a tool somewhere that generated sprite sheets from MPEGs, which I could have done. But one of the things that I wanted to do, I'm just going to show the output actually. Let's just go and have a look at the final version of the code so you can see what I'm talking about. One of the things I wanted to do was read in a GIF, because GIFs are 256 colors, or these ones are anyway. And we can also sort of run them at low frame rate and have this cool dithering effect. So it looks much more like a sort of 1995 CD-ROM FMV game might have looked. This is it running at sort of 60 FPS. Now in the game we're deliberately going to run it at 12 FPS because that's again more authentic to streaming from a CD-ROM back in the day. People did not have fast video unless they did it on a small part of the screen. And this is actually a 640x480 GIF that's been expanded up, doubled in size for this test purposes. The doubling in size takes nothing on a modern hardware but would have back in the day. But back in the day it was common to have 640x480 resolution in about 95, I guess. So yeah, I wanted to, instead of using sprite sheets, I certainly had no ability to do MPEGs and stuff like that. I wanted to read in a GIF file, animated GIF, and stream it in our game. And this is just test code, but this kind of movie will be in the final game, modified with voiceover and music and so on. So what I did is I got some, I'm going to shut this down a minute. I got some GIF reading code from the Syntax Bomb forums, which are BlitzMax forums, and somebody else had got some even older code by someone, and then from 2008 some GIF reading code, and then in 2022 they'd done their own version of it. It was actually written for BlitzMax NG, and I had to tweak it a bit to get it to run. And basically this reads in an animated GIF file, and will then, there's a little bit of code down here which draws it on the screen. And that worked. And I was like, okay, that's the basis of what I need. There were a few problems with this code, right? One of it, which it was too slow, and through various optimizations, I sped it up almost 3 times. So if I run this the first version, it won't show anything on the screen because it's doing everything in the background. And it says it took 3,500 milliseconds to basically decompress 300 frames, okay, and sort of get them in the memory ready to draw. Now, that's okay. I mean, but this is an issue, right? So if we had this running in our game, the player would have to wait 3.5 seconds for it to load in ready to play the movie. Now I've got a kind of more or less brand new PC, and I ran this on my MacBook Air from 2017, and it took 12 seconds. So that is a lot slower. And there are obviously older PCs out there, and it would run even slower. And if you get to the point where you're waiting longer to load the movie in than it takes to render, then that's a real problem. So I didn't want it to take 3,500 seconds to read it in. Or, as my ultimate aim was not to read it all in due to memory issues, because if you read in a minute-long GIF file into the memory and extract every single frame as a sort of texture in the memory, it's going to start taking up a lot of memory. And that's actually a problem for BlitzMax because it's 32-bit and it runs in a 32-bit memory space, which means it can only address 2 gigabytes of memory, and that becomes a problem which I'll show you later. So I didn't really want to read it all in the memory anyway. I wanted to stream it later on, and then if it's taking, like this code which ran here, it's basically taking nearly 12 milliseconds per frame to decompress it. And on a slow PC like on my MacBook Air, that was 40 milliseconds. So you can begin to see the problem. Now, we want to run the movie at 12 frames per second, which is 83 milliseconds. And, on a slow PC, imagine it took longer to decompress each frame than the frame rate I was trying to do. You'd end up with skipped frames or lag or something. So I knew I needed to speed this code up quite a lot. And I went to work sort of using my old school optimization skills. And I'll kind of show you what I did there. So let's have a look. Oh, and one thing to say, by the way, also on my PC, rendering each frame, so putting it to VRAM and on the video card and getting it on the screen, takes just over 1 millisecond on my PC, very fast. But on the MacBook Air, that was like 7 milliseconds. So you could add that as well to streaming. Imagine it was 40 milliseconds just to decompress a frame, 7 to render it, that's 47. We're getting really long. And if we wanted to show video even faster or something, this is a problem. I also tested this same code on, this is running off an SSD. I ran it off a hard disk drive to see if that would speed it up and slow it down. And it's not really any different, because I think once the file is read into the memory, I mean, it's supposed to be streaming the file. It's opening a stream, this code. Let me see if I can find it. Stream. I type Steam, old habits, I guess. Stream. It's reading in a T stream in BlitzMax, which is like this sort of C++ streams. And, you're thinking, is it reading each byte off the disk as it progresses and looking for end of file in that? Probably not. It's probably cached it in some way. So that's why running it on a hard disk drive wasn't really any slower than an SSD. Like the initial reading is super fast of both of those things, because in fact, sorry, let's close that one down. The video I'm reading in is this one, and it's 46 megabytes. And these days, 46 megabytes is read in a flash from literally SSD, flash memory, or hard disk. It's not slow. So that really wasn't part of the thing. In fact, I checked the loading time, and I think reading the file in was like 50 milliseconds of the 3,500. So that's not a slowdown. So, I wasn't getting a falsely fast reading just because I had an SSD. Okay, so one of the first things I did was track how many times each function was called. And this is the original code, GIF class test. And this is the final one, GIF class test 4, which I tidied up and commented and the changes I made and so on. Now in this old one, I'm not sure if I've got the right function. Yeah, function counter. So I made a thing called function counter, and I just literally, whenever there was a function I wanted to see how many times it was called, I just put this in it, right? So this GIF code is two classes. There's the main sort of class tGIF, and then it creates a GIF frame and reads in that frame, and then it stores all of the frames in a kind of list so that you can then render them. So which is fine. But in this GIF frame, this is the one where there's all the functions which are called many, many times, right? So this is the main code, decode GIF, which goes through the GIF and calls a bunch of different functions. And this decode GIF is called 300 times for 300 frames. So it's only once per frame. So I didn't need to worry about optimizing the overall function of that. But the fact it was calling a whole load of these things like stack, GIF outline, poke buffer, all of this sort of stuff. All of these are functions beneath here. And I wanted to know how many times they're called. And my function counter told me that some of them, like this one called stack, was actually called 300 million times. Okay, so I guess about 1 million times per frame, which is quite a lot. And therefore it was ripe for optimization if possible. And some other ones that were called 90, where's poke buffer? Poke buffer was called 91 million times, this one. And something else 48 million times. Where was it? GIF next code 48 million times. So quite a lot of times. So they were the biggest, well, the ones that were called the most times, and the ones which I thought I better optimize. Some of them were only called 300 times, i.e. once per frame. So I didn't really need to do much or any optimization there. It's best to focus on the things that I needed to do. So one of the things you do with optimizing an old school method is to inline code. So instead of whenever it's calling stack, instead this is, you could imagine there were brackets around this. This is a function, okay? So instead of calling this function called stack there, and if we go and find stack, here it is. Instead of calling that 300 million times, because whenever you call a function, right, the processor has to sort of like jump from the code that it's running at the moment, this main decompression loop, go to this function, passing in variables, right? It has to sort of do all of this, return a variable and jump back. And there's a lot of overhead in jumping somewhere else and passing variables. Now, modern compilers can do a lot of optimization, I believe, with this stuff. And you can even tell it, hey, this function, actually, I want it to be inlined. And so it won't really call it. It will act as if that function has been copy pasted here, right? So instead of like, where are we? Gone lost it again. Right, so instead of it calling this, it would do something like, it would be the equivalent of having this select statement whenever stack is called. So there's a stack, so we'd have that instead of stack, and that's commented out, and you do that multiple times. So I can either do that manually, or I could have let the compiler do it. Well, I wasn't sure the compiler was doing it in this case for BlitzMax, so a modern one would do it, as I said, with an inline command, or it might even do it intelligently if it knew it was going to be used enough. So my first port of call was inlining stack. And actually, one of the things I realized it was kind of, I don't want to diss the original programming too much, but kind of a bad idea, was if you know how a stack works in assembly language and stuff, you're basically putting a variable on it and then taking it off the top of the stack when you need it again. It's like a quick sort of storage zone. It's like, oh, I'll put that over there and now I need it back. And so this function you can call with a mode parameter. They've fetch it from the top of the stack, push it to the stack, or just find out how big the stack is. So it's a nice, neat bit of code. Sure, you know, you pass in a mode, there's a select statement. These are called switch cases in C++ or C#. It's just called select case in BlitzMax. It's the same type of structure. So it looks at the mode and then it does something and returns a value and everything. Now, if something's called 300 million times, you do not want any decision-making code in there at all. And having a select is a decision-making path of code. So the first thing I did was I didn't get this whole thing and paste it up here. I said, wait a minute, whenever it's wanting to call it with fetch, so if I look at, I've lost it here, decode give. So let's look for stack here. Right, so it was either sending in push or fetch or whatever, and instead of calling this at all, I just looked at the code. What was push doing? What's push doing then? So push is going, oh, it's got this stack, which is a pointer to this global here, stuff a value in it and increase the pointer on the top of the stack. That's all it's doing, right? So I just pasted this into the code above instead of the whole thing. And when it called fetch, I would only paste this in. And when it wanted the size, which skipped this whole thing, I would just look at the pointers, which is this current size. And we can sort of see that if I go to the final code, I'll just go over here a minute, decode GIF. Okay, so looking down here, somewhere, yeah, this is the old function for push. So this was actually calling a function, passing in push, old code, and it was doing all that decision making, and it was basically replaced by these two lines, right? So I did this throughout this function. So I replaced stack with, you know, smaller versions that were inlined, and that sped it up quite a lot. I think I made a note here. Did I have a look there? Oh, I thought I made a note how much it sped it up. It definitely sped it up quite a lot, because 300 million times of, you know, decision making, so I got rid of that. Similarly, there was another function called poke buffer. Let's go and have a look at this. That was being called, you know, 91 million times, and it was poking something into a buffer and increasing some pointers and then making some decisions and returning. So again, there was a lot of overhead, especially passing in like this many variables. That's quite a lot. So if I look for, go back to my GIF, see what I did in the end, I should be able to search for poke buffer. If I kept the other one, yeah, so it said it was calling a function like this with all these parameters, but in the end I just needed to do poke a byte into a buffer and do a couple of extra things, right? So, and I did that a few times down here. So that was like inlining. So this GIF decode GIF. It's a short function in this original code. Where is it here? So it almost fits on one screen, which is, okay. It was neat and it called various other stuff. And now my new one, basically because I've inlined poke buffer and stack and a few other things, is a bit longer, but not that much longer, right? So, and there's repetition, which, people don't like. They're like, oh, if you've got to repeat it twice, you should stick it in a function or whatever, or a class or something. And it's like, not when you're optimizing something that's got to be called this many times. You want it all in the main loop. So, I mean, a lot of people look at this and go, oh my God, you wrote something with more than 10 lines in a function. Yeah, because this is old school code. It has to run through this thing a lot of times, and you don't want it branching off anywhere else or doing anything else. And then it can use the CPU can use registers that are right there, that it's got access to. It's not having to write them into memory, get them back from memory. It can use caches that are really close to itself, so they're not off in some other part of the memory. So all of that stuff can speed it up. So yeah, I did that. I also optimized GIF next code 2. Let's have a look at that one. GIF next code 2. Let's have a look. Oh yeah, I took out the end of file because it never actually occurred. So I just sort of commented that out. I didn't want it to be doing any kind of file testing. What have I got here? I'm just checking my notes here. Just bear with me. Yeah, actually that didn't make much difference. I thought it might make more difference, but I think it's because it was in this bit of code here, which I don't know. It just didn't make much difference. It must have been a very quick function call. So I sort of I didn't inline that into the main function. I inlined it into GIF next code, which calls GIF next code 2. So unfortunately, this little function here did sort of swell up in size because I had to essentially paste the function above it in twice and optimize that, which I did, but it didn't make as much difference as I had hoped. So turns out this one was fairly quick. Other things I did were the original code. It had stuff like, let's have a look, interlaced. Let's have a look. It was doing checks to see if it's interlaced and it had a whole function and was doing a whole load of code related to that in this GIF line out. And also it assumed it could be different color depths. So every time it was calling this, it was doing a sort of case statement for copying various buffers. So I said a switch case statement. So, and it could have been different bit depths. But because we're using a GIF which is 8-bit depth and wasn't interlaced, this whole thing was like massively optimized. So GIF outline, there it is, I think. Yeah, so I commented out all of this decision making, inlined this function, which was copy buffers. I just pasted it in here and I didn't do anything with the interlacing. So all of that, sped that up a bit anyway. So after all of this inlining stuff, I sped it up and got it down to 9.7 milliseconds. So that was from like nearly, was it 12 milliseconds? So I shaved off 2 and a bit milliseconds maybe. So it wasn't that impressive, even though I'd spent all this time inlining stuff. It was fun, and it was fun to do, and it did speed it up, but not tons. So 12 down to like 9.7. I mean, not a lot, but yeah. Then I did. Let's see, what did I did? Oh, sorry. I after poke buffer, I got it down to 9.3. So yeah, it was getting a bit better. 2.5 milliseconds shaved off. But then I did one of the biggest things, which is, of course, it's using a stream, right? So if I look up, I was using a T stream, which is a file stream. This was the old code. It was reading in a stream and then doing stuff like read byte from the stream and checking end of file and jumping around within the stream. And instead of it being file based, I wanted it to be RAM based. So there's a thing in BlitzMax called a RAM stream. So here I created a RAM stream instead of a file stream and just read it into that. Well, before that, you read the file, the URL, into a byte array. Now, a byte array is just an area of memory. It's just here's a block of memory, read the file into that. So it's as kind of basic as you can get, and then you create a RAM stream from that so that it can step through it as if it was a file, but it's doing it in the RAM. And that sped it up a lot. I didn't really need to do anything else. It was just literally changing this code around, and we got from 9.3 milliseconds down to 6.2. Now this is now twice as fast as the original code, okay, with some optimization and this RAM stream. Now bear in mind, if I hadn't done that other optimization, it would still be 2.5 milliseconds longer. So it wouldn't be 6, it would be like 8.5. So that's why that initial optimization, it didn't seem that much. It does count when you get all the other stuff optimized. So anyway, RAM stream was pretty good one. Now the other issue was, let me see. Yeah, the other issue was it kept using a thing called read byte. Okay, so here we go. Oops, misspelled that. Sorry. Read byte. So the other issue is, like when it reads in the header, this is fine. This happens now once in the code. It reads in the header. It's okay to use the file stream or RAM stream to read some bytes out. No problems at all, right? And maybe it's the sort of things where it happens only once per frame. I think this was maybe happening once per frame. I'm not sure. That's okay as well. But there was some code. Where are we? I'll just go and find it. I probably commented it out. Yeah, this is all just reading in the header stuff. Yeah, GIF next code. Oh, that was the one. So this was using read byte. And in BlitzMax, this read byte is using some underlying C++ code, and it's probably using some kind of Windows OS code or whatever. So whenever you call read byte from a stream, there's some overhead, and I changed it because I'd read this block of memory in earlier called temp byte array. I'd set that up earlier. I changed it so instead of using read byte, I would just use this memory instead, and then keep my own pointer. This is temp pointer to that memory, because obviously the advantage of a stream is you tell it to read a byte and it advances its internal pointer on by 1, so you can just do read byte multiple times in a row. It knows where it is. You can check for end file and stuff. But in this case, because I was pointing at just a block of memory, I needed to keep my own pointer and then track the progress. But I did that in a couple of places here, replacing read byte, and I think I did it somewhere else. Oh, I can't find it now, but that sped it up another 20%. So that was pretty good. Now I was down to the sort of 4 point something milliseconds per frame. So definitely, look at anything which is using some kind of any file system stuff. Can you just stick it in the memory and step through the memory? This is the closest to the way the PC works internally, right? The CPU reading the memory, or better than that, reading a cache, because it's probably, if it's using this memory a lot, this temp buffer, it's basically going to be keeping it in some high level cache and stepping through that. So we're working in a way that the system wants to work, basically, instead of going out through all these read byte stuff. And who knows if virus killers get in the way and slow it down, or anything else in the OS might slow down some of these more sort of involved functions. Okay, what else did I do? Oh yeah, one small thing in GIF next code. I tried this. This is a little point to things. It didn't speed it up much, but I did see a change. Where are we? Yeah, it was using tgif, which is another a class. Actually, this was a global within this class. I was using tgif temp pointer all the way through this code, and then I just made a local copy of that. Okay, and then at the end I have to write it back to the other thing, right? So this appears to be more code, right? Because A, I'm making a local copy, and B, I'm writing it back. So yeah, sure. But the thing is, it was used a lot, this pointer, especially down here. This is like a loop. So it was doing a lot of stuff with this temp pointer. And having to go out to another class and read a sort of global variable within that class obviously took time, right? So the CPU wasn't reading it from some very local area of memory. It had to go and get it from some other area of memory, and it took slightly longer than making a local variable, which it probably kept in a CPU register. and then it was able to just use the CPU register all the way through this function, and then I write it back at the end. So that sped it up a bit. So that was kind of interesting. I tried a similar thing here with a pointer to the array that I was using. So I sped it up. I tried to speed it up with temp B. So that's just a pointer to the byte array. And it literally didn't speed it up at all. So I guess that whenever that was accessed, the CPU or compiler had already optimized putting that into some kind of address register on the CPU, and it was already as fast as it could be. So that didn't make any kind of change. So yeah, after I did all of this, I basically got it down to 4 point something milliseconds, I think. And there was one last change which sped it up some more. Clear pixels. Let's have a look. There we go. Yeah, this bit of code, process image data block. I can't remember if that's what my own function name or not. Yeah, here we go. So what this did was it was clearing basically the code creates in BlitzMax what we call a pix map, which is an area of memory, and that clears it, and then it reads in the GIF. And you can see the issue here is, like, you do need to clear it because otherwise that memory is full of junk. So you do need to clear it before reading in each frame of the GIF. The thing is, the way GIFs work is each next frame is based on the previous frame, and then you just log the modifications. So you don't need to clear every single frame, you only need to clear the first one. And I suddenly spotted that, and that's why I was able to change the code around so that only for the first one does it clear, and then all of the others it just copies the previous one or whatever. So there was some redundant clearing, and when you're clearing, you know, a 640 by 480 block of memory, it's not nothing, and it's going to slow it down. So after all of that, I got it down to 4.37 milliseconds, which is approaching 3 times as fast as the original one. 4.37 milliseconds to decompress each frame on this PC. But remember, some PCs, well, my MacBook Air and some other people's PCs were like 3 times slower, and some customers' PCs could be 5 or more times. So that could easily go over 20 milliseconds, which is over 60 FPS, which is 16.7 milliseconds. So we didn't really want it to go over that in most cases, but it was okay because all of our movies we're trying to run at 12 FPS. And so I've got up to 83 milliseconds before it would start lagging. And that's unlikely to happen. And if it does happen on some people's PCs, then they probably need to get a new PC at this point. Or, you know, I'll look at doing some kind of other code if I get any complaints, but probably they won't be using anything that old and rubbish. Whereas with the original code that was 3 times slower, we might have entered a sort of realm where quite a few customers were seeing problems, and I didn't want that to occur with this game. Plus it was fun optimizing, and I couldn't stop myself until I'd done as much as possible. So one of the other things that was happening in the old code, where is it? There's some kind of code that reads in the header. Here it is. And it was doing this every frame. I don't know why. Maybe because of the way it was originally structured and then modified. It was reading in the GIF header every single frame and the palette, all this kind of stuff, the width and size of the image, and then decompressing that frame. And I'm like, well, why is it doing that? You know, it should read the header in once. So I changed my code round to sort of read the header in. I moved a whole load of variables out of the frame and functions into this, so it just reads the header once, okay, and then obviously stores those things for use by the decompression algorithm later on. And I thought that would speed it up a lot, but surprisingly it didn't. I guess the header reading code was quite fast. There's only 300 frames, so even though it was being called 300 frames, 300 times more than it needed to be called, it wasn't that much compared to other things I did that were called 300 million times, for example. So sometimes you can do false optimizations, but I also found it confusing having it reading the header in every frame, and I much preferred it reading it at the top level. So I did that, and there was no real change. So we'll talk about another issue which cropped up, which was this was a pretty bad issue, and I knew about it from working on Shadowhand Solitaire, the original Shadowhand game in 2015 and so on. That's a collectible card game, and I read in all of the cards as the game loads. and I read in all the game graphics at the beginning because I like it to be fast when players are then playing the game. I don't want to have to be loading in stuff dynamically and slowing stuff down. So I read all the graphics in and put it in the VRAM actually when in my old game. And then I was encountering these DirectX errors about out of memory, and I knew that existed, and it would happen when I got to maybe approximately a gigabyte of VRAM used. And I thought, that could occur here when reading in and displaying a movie easily, right? You could easily fill up, like even though it's a 40 gigabyte film movie, well, are we there? 46 gigabytes. When you extract let's get the calculator out here actually. So if we've got 640 by 480, that's your image size, right? So, but when it's in the memory, that's 4 bytes per pixel because it's an ARGBA pixel. So we're already like 1.2 megabytes per frame. But then the issue we've also got is video, at least the way the DirectX library is written for BlitzMax, and I've looked it up. There used to be an issue with old video cards where the textures had to be rounded up to power of 2 sizes. So if you've got some, that basically means binary. So like 2, 4, 6, 8, 16, 32, 64, 128, 256, 512, 1024, etc. So if you have a 640 wide image, the internal texture will actually make it 1024. And then the 480 high will actually end up being 512. So you end up that much times 4 bytes. So you end up with 2 megabytes per image per frame. And then, 300 frames, we're starting to get like quite a lot of memory use going on here. And the way DirectX works, which I looked into this, is it keeps a copy. Well, okay, so my game was keeping a copy of the texture in the memory, and then on this code, and DirectX keeps its own copy, right, so that it can upload it to VRAM, and then when in VRAM, if it ever gets trashed or it needs to upload it again, it can upload its own copy. So you end up with this sort of like times 2 in the memory. And what I ran into was this issue where, because BlitzMax is a 32-bit app, it's limited to this 2 gigabytes of addressable memory. And if I was reading in the whole movie in one go into memory and then trying to render it, so sending it to DirectX to put into VRAM, DirectX 9. This issue, by the way, went away with DirectX 10 onwards, which became 64-bit, right? DirectX 9 was the last 32-bit one. What would happen is, this is trying to sort of read in and show each frame, and you start to get these errors, DirectX errors, unable to display. And first it's fine, and then the memory fills up, and then you get these errors, and it can be slightly inconsistent. So I knew that I couldn't read in a full 25 seconds. This is only 25 seconds at 12 FPS, but it's only 300 frames, right? And bang, suddenly out of memory. Imagine we wanted a 1-minute movie. We'd definitely be out of memory there, or a larger film or something like that. So unfortunately, this original code, which it basically read in all the frames and then just drew them in a loop, wasn't going to work for our purposes. So especially if you think about a game, there's a whole load of VRAM used up for everything else in the game, not just the movie. This was just test code running only the movie. In fact, I should actually, let's go back to that. I've got, let's just go back a sec where we are here. I've got Task Manager open, and if we put Task Manager here, when I run this, where's Task Manager, right? You'll see the code at the top, the memory use sort of shoots right up as it reads everything in, and when it hits like the 1 gigabyte, it crashed. So I'll try that again, and you should be able to see there's a memory usage shooting up. It's going to go to about a gigabyte, bang, or just over, and suddenly it can't create the textures anymore. So that's what I mean, right? You're running out of memory. So obviously the solution is to stream. That's what they did with CD-ROMs back in the day. And if this was streaming instead of making use of a modern PC's memory, because by the way, in 1995, PCs did not have anywhere near the amount of memory I've got here. And that's why people were like, kind of like, you'll never fill up, 1 gig of memory and stuff. And even when DirectX 9 was around, I think the average PC had like half a gigabyte of memory, and I've got like 32 in this. So going over 1 gigabyte was not common, and people were using a lot lower resolution textures and or streaming movies. No one would think to read in a whole movie and display the whole movie, right? Which is what this code was originally doing. So obviously I thought I need to stream it, and I basically changed the whole code to where is it? Yeah, it basically streams. I mean, I don't think I need to go into detail here, but it reads in 1 frame, puts it in the memory, shows it, and then clears it. And that was another issue which I came up with. If I look at for GC collect. Oh, I didn't mean to do that. GC collect. Here we go. Clear frame. Maybe I did that myself. Yeah. I made a function called clear frame, which clears the last frame from the memory, because I can actually, in something like C++, you can null a variable, and the garbage collector will just clear it when it needs to. But again, if you're showing a movie really fast or reading it in, you can still run out of memory if the garbage collector is too slow, right? And I ran into that issue. So I have to manually call the garbage collector every time I've shown a frame. So I show a frame, display it on the screen, then I call clear frame, which calls the garbage collector, and that keeps the memory down. And if I run this in and show you Task Manager, you'll see the memory is 70 megabytes, right? And then it actually drops down when the movie's been shown, because it unloads everything from memory, just keeps the last image. And if I run it again, you'll see it pop up here, 70 megabytes, right? And that's it. So instead of it going over like up to 1.2 gigabytes, it's got 70 megabytes, which would have been much more realistic in 95 maybe even that was too much for 95. But anyway, it's not much. And furthermore, the original code wasn't able to run multiple times in a row without crashing. It wasn't written that way. It just kind of written so you read it in once and that's it, which we couldn't have. I need to have a game where you could view the same movie multiple times or different movies in the game. So I just made sure it could loop over and over, which it's showing now with this code, and keeping the memory use that low, no crashes, no memory leaks. It's not gradually creeping up, no problems like that. I mean, a lot of people use a modern kind of debugger and check for all this stuff, but honestly, Task Manager is pretty good for that. And you can see it's counting in all the frames here, and whereas it was crashing before around frame 250 with DirectX, it's not crashing here. And I should note that actually the same issue doesn't occur in OpenGL, so we can actually use an OpenGL graphics driver with Blitz Max, and it didn't appear to occur at the 1 gigabyte limit. Maybe it would have occurred at 2 gigabytes. I'm not sure. Maybe OpenGL works totally differently and was already 64 gig, the version I have, 64-bit. I don't know. But the game is targeting DirectX or OpenGL. Actually, our players can change graphics driver if they want, but the default's DirectX. So yeah, in summary then, I wanted to get GIFs read in as FMVs, or FMVs read in from GIF files. Basically, I optimized to 8-bit, non-interlaced, got it down from 12 milliseconds per frame to 4 milliseconds on my PC, but that could be a lot slower on other PCs. That's the decompression. And then I made it so it didn't read it all in, it's actually streaming it. The code though is written actually so that I've got a little constant here. If I set it to 1, it will read them all in. I think that might still work actually. Let's just try. I don't know if I left that functional. If I buffer them all instead, you can see the memory use shooting up here. Yeah, now it doesn't crash anymore. It's only using half the memory because I used a slightly different technique to sort of read in, and I free up each frame after I've viewed it, I think. But I think DirectX is still keeping a copy of everything. I'm not sure. Anyway, the point is this version still uses a lot of memory if you're buffering it. And we might do that for some small movies in the game, like just like animated backgrounds and stuff. We don't, where's the buffer frames? Here it is, 0. Put it back. So if we've got a short movie, a few seconds, we might just read it all in, because it would take probably a second max on slow PCs. Loop that in the background somewhere, and there won't be any decompression each frame, so the mouse cursor will move around fast on top of it. If it's slow, it won't be slow because it's just rendering the images. But for longer movies, we will use this streaming system, and the longer movies will just be playing full screen anyway, so there won't be this sort of screen where you need to move a mouse around. So if each decompression takes longer than, say, 160 FPS, 16.7 milliseconds, maybe it would take longer, you won't notice really, because you won't have a mouse, so you won't be doing anything. You'll just be watching the film or clicking to end the film. So there's two different use cases, right? Buffer a short film where we think it can fit in the RAM and VRAM safely, or stream one instead. So I think that's the conclusion. And also this code here, I neatened it all up, made it sort of properly reusable. Then I put it into our main project, and I've called it for the intro movie, and we're going to have obviously an outro movie and a few other movies in different places. It's not really a full FMV game. People make a lot of assumptions when they read your initial pitch, but there will be some kind of air quotes FMV in it. It will look kind of authentic to the period because it's coming from GIFs. It's not read off a CD-ROM, it's just a file that's read into RAM, to be honest, and then streamed from RAM, because we can do that on a modern PC. So that's what this code will do. Anyway, I've probably gone into way too much detail for most of you. Old school programmers will recognize what I did. And yeah, this code does not look nice. And look at all the stuff I commented out. I got rid of all these functions that either weren't used, or I inlined them. And and I got rid of various streaming stuff and just made this main function slightly longer, and this one here like a bit longer than it needs to be with some inlining. Yeah, and it's messy, and I've kept the old code there for now. I think I've deleted it from my internal copy that I'm using in my code. I shared this back on the syntax forums because I got it for free off there. I put my code back on there. It felt nice to be able to do that and say, look, this is faster, but it's got specific use cases, right? 8-bit color, non-interlaced, but that's fine. And people may never ever use this, and maybe I'm the only person who used the original guy's code, who knows. But it was nice to do that. So in conclusion, please keep an eye out for Forbidden Solitaire coming soonish to Steam. Definitely watch the trailer if you haven't seen it already. There's a really awesome trailer. This is the movie that you see in the game that I've turned into an FMV. We've got these news clips and things in here. It's quite a funny trailer. So, have a look out for the game. Hope you enjoy me waffling about optimization, and I'll see you around. Thanks for watching. Bye.